Okay, good morning. We're going to do lesson 4 as a series of screencasts that you just need to follow along and listen, take notes, underline, and basically do what I do and listen along. We're going to talk first about electromagnetic radiation. And even though you probably have not heard the term electromagnetic radiation before, you probably have some familiarity with things that are considered electromagnetic radiation. Electromagnetic radiation is just waves that are emitted that disturb electric and magnetic fields. Light, visible light, is one variety of electromagnetic radiation, but it's not the only type. It's the type that we think about the most because that's the type of electromagnetic radiation that we can pick up with our eyes and sense as a visual picture. But there are other types of electromagnetic radiation. And what type of radiation you're describing has to do with how long or short the wavelength of that radiation is and how high or low the frequency of that radiation is. Okay, so just to give you kind of a basis of comparison, visible light is a form of electromagnetic radiation that we're able to see, pick up, visual information with our eyes. But there are other forms of electromagnetic radiation that either the wavelength is too short or the wavelength is too long, or the frequency is too high or too low. And we can't perceive that with our eyes. Things like the bell ringing. Ultraviolet radiation is a form of electromagnetic radiation. We can't perceive ultraviolet radiation with our eyes, but if you've ever gotten a sunburn, you have felt the effects of that particular type of electromagnetic radiation. X-rays are also a type of electromagnetic radiation. That particular form of radiation is used in imaging, CT scans, your typical X-rays, things like that. Because what it does is it sends those high energy waves, they penetrate right through your soft tissue, but are absorbed by bones and things like that, and so it creates a picture using X-rays. Gamma rays are an even higher energy form of electromagnetic radiation. It's the highest frequency and shortest wavelength. Very, very high energy. Bad. Let's not be exposed to X-rays or gamma rays. Okay, but these are all electromagnetic radiation. Gamma rays are the shortest. X-rays are a little bit longer wavelength. Ultraviolet's a little bit longer wavelength than that. Visible light, the light that we can perceive with our eyes, is a little bit longer than that. And then a little bit longer than visible light is something called infrared, and that's what we pick up kind of as heat radiation a lot of times. Okay, a little bit longer than infrared is microwave radiation. A microwave oven, for instance, uses microwave radiation to give energy primarily to water molecules to heat things up. And then the very longest type of electromagnetic radiation are radio waves. A radio that you listen to is called a radio because it picks up radio waves and converts them into sound waves that you hear. You cannot hear radio waves. Radio waves are a form of electromagnetic radiation traveling at the speed of light, but when your radio picks up those waves, the devices in the radio convert those signals into sound waves, which you can hear. Okay? So all of these different things, radio waves, microwaves, infrared rays, visible light, ultraviolet, X-rays, and gamma rays, those are all forms of electromagnetic radiation. And they all travel at the speed of light, which is 300,000 kilometers per second. And the only thing that's different about them is the amount of energy they carry and their frequency and wavelength. Okay? All right, so I'm going to have you turn your paper, and I would like you to write this. I found a space to write it on the side. Objects in the universe give off energy in many different types, and visible light is only one type. We have a star in our solar system, the sun, which gives off a lot of visible light. That's what we perceive with our eyes, but it also gives off a variety of other types of radiation. But we need other instruments to pick up those types of radiation. Okay? But you just need to realize, and it's really important for you to realize, that objects in the universe, stars, galaxies, nebulas, all of those things, not only can you see them with visible light, but you can also detect the other types of radiation that they're giving off, whether it's X-rays or radio waves, infrared rays. Okay, so they're all giving off energy in a variety of wavelengths, but the only thing that we see with our eyes is what we call visible light. Okay, so visible light is only one type of electromagnetic radiation. Okay, so back to what we've... Okay, so let's go through the notes. Energy traveling as electromagnetic waves is called electromagnetic radiation. Waves or radiation can be described by either their frequency or their wavelength. Wavelength is the distance between two adjacent crests, high points, or two adjacent troughs of a wave. A trough would be a low point. Frequency is the measure, the number of waves that are generated every second. Okay, so the more complete waves generated per second, the higher the frequency. Okay. A higher frequency wave carries higher energy than a lower frequency wave. That's what this arrow is trying to remind you of. Okay. And up here I wrote a reminder about high energy waves. High energy waves have a very high frequency and a very short wavelength. The high energy waves, basically for us, we consider high energy waves the things that are shorter wavelength than visible light, ultraviolet, and then particularly X-rays and gamma rays. Okay, those are things that if we're exposed to them, they can be very harmful. Luckily for us, though, the atmosphere takes care of a lot of protecting us from a lot of those really high energy waves. Okay, so then we're going to go down here. How's electromagnetic radiation classified? All of these wavelengths and frequencies make up what's called the electromagnetic spectrum. And just in general, not just in science terms, but the word spectrum just means like a continuous range from one extreme to the other. So when we talk about the electromagnetic spectrum, we're talking about electromagnetic waves from the very, very longest wavelength, like radio waves, to the very, very, very shortest wavelength, like gamma rays. Okay? So it's a spectrum. It's a range of all of our possibilities. Okay? So like I said, lowest wavelength and longest lowest frequency and longest wavelength are your radio waves. If you're exposed to radio waves, it's no big deal because they are low energy waves. Microwaves are a little bit higher energy than radio waves, but still they're fairly short. They're fairly long. They're shorter wavelength than radio waves, but they are fairly low energy also. Okay. Then getting a little shorter is infrared radiation, and this is what we sometimes wind up interpreting as heat. Visible light is a little bit shorter than infrared. By the way, on visible light, the longest wavelength of visible light that your eye can detect is red light, and the shortest wavelength of visible light is violet. So if it's a little too long for red, it's infrared. And if it's a little too short to be violet, it's ultraviolet. Okay? All right. So even shorter than visible light is ultraviolet radiation. Shorter than that is X-rays and gamma rays. Okay. Write the parts of the electromagnetic spectrum in order from lowest frequency to highest frequency. Okay, voila, it's appeared magically. So the lowest frequency and longest wavelength is radio, a little bit shorter is microwave, a little bit shorter than that is infrared, a little bit shorter than infrared is visible, a little bit too short for visible is ultraviolet, shorter than that, X-ray, even shorter than that, gamma ray. Okay, remember, gamma ray is your highest energy wave. You do not want to be exposed to gamma rays. And radio is your lowest energy. Okay. All right. All right, number 7 says electromagnetic something that has a shorter wavelength has a, okay, electromagnetic waves or electromagnetic radiation that has a shorter wavelength has a higher frequency.